Today we're going to look at sections 5.4 and 5.5, which is graphing each of the 6 trig functions. So first we're going to look at sine, cosine, tangent, and then we're going to look at their reciprocal functions of them. So if you notice in your notes, each one of these has a table right here, and this is basically our quadrantal angles. So we're going to evaluate our quadrantal angles first, try to get a table set up, and then after we get our table set up, then we can take these and construct our graphs. So first thing we're going to do is we're going to look at sine theta. So I've got my chart right here that we constructed last week, and I'm going to find each of these quadrantal angles based off of sine. So the first place I'm going to start at is 0, so the sine of 0. So the sine of 0 is just plain old 0. So this is 0. Now I want to find the sine of 90. The sine of 90 degrees is 1. Then I want to go with 180. The sine of 180 is back to 0. 270, the sine of 270 is at negative 1. And then 360, the sine of 360 is 0. All right, now, going with my negative angles. First thing I'm going to look at is negative 90. Well, if we don't like negative angles, we can always take this and turn it into a coterminal angle. So I'm going to take negative 90, I'm going to add 360, and that's the same thing as 270. Well, we've already evaluated sine of 270, we got out negative 1. So the sine of negative 90 is the same thing as the sine of 270, which is negative 1. All right, then we got negative 180. If I take negative 180 and add 360 to it, that gives me out positive 180. So the sine of 180 was 0, which means the sine of negative 180 is the same thing, 0. All right, then we've got negative 270, coterminal angle, adding 360, that's the same thing as 90. The sine of 90 is 1, so the sine of negative 270 is the same thing, 1. All right, then the last one we got is negative 360. But if I take negative 360 and add 360 to it, it's the same thing as 0. And the sine of 0 was 0. So we've used our unit circle table as well as coterminal angles to fix this chart. All right, now let's just graph these points right here. So let's just first start at 0 right here. So I'm going to graph 0 degrees and then 0. Now, as you notice, my axis is not labeled. So the first thing I'm going to do on my axis is label the x and the y axis. So my x-axis is going to be my degrees, and my y-axis is going to be my sine right here. So I'm going to go out 3 units right here, basically to represent 30, 60, 90 degrees. So this right here is 90, and then 3 more is going to get me to be 180. 3 more is going to be 270, and then 3 more is going to be 360. So each of my graphs are going to look like this. All right, going backwards, I'm going to do the same thing. So 3 units to the left is negative 90. 3 more units is negative 180. 3 more units is negative 270. And 3 more units is negative 360. All right, going up, I'm just going to go by 2. So basically going by half. So if this is a half, this is going to be 1. This is a 1.5, so this will be 2. And then up here will be 3, but I'm not going to write that quite yet. All right, going down, I've got negative 1 and then negative 2. All right, so there's my axis labeled, so you know that my x-axis is in degrees and my y-axis is just numbers right here. All right, so now let's take this thing and graph it. So the sine of 0 is 0, so that's just the point 0, 0, which is basically just the origin, 0, 0. All right, next point is 91. So at 90 degrees, I'm going to go up to 1 and put a dot. The next one I got is 180, 0. So at 180, I'm going to come back, put 0. The next one at 270, I'm going to negative 1. So here's 270, and I go down to negative 1. And then 360, I'm back to 0. All right, let's go the other direction. Negative 90, I go to negative 1. So here's negative 90, I'm going to negative 1. Negative 180, I go to 0. Negative 270, I'm up at 1. And negative 360, I'm back down to 0. All right, now I'm just going to connect these dots. Now notice that this right here is not just going to make these. Okay, these things are going to be curved around. So it's going to curve up to have this being a concave down graph. And we've talked about that back in Algebra 3. Then I'm going to curve this one up and put an arrow on the end because this function is a continuous function right here. All right, going back the other way, I'm just going to curve this down, go through 0, curve it, and then go back to negative 360. All right, so this is the graph of sine theta. All right, now let's look at cosine theta. Before I look at cosine theta, I'm going to label my axis just like we did before. 1's negative 1, 2's negative 2's. And then my x-axis, remember I'm going by 3 units each time. to give me my quadrantal angles. All right, so these are my positive quadrantal angles. 90, 180, 270, 360. Then I'm going to go backwards to get my other one. Negative 90, negative 180, negative 270, and negative 360. All right, now let's look at cosine and the points that actually go with cosine. All right, so here's my chart. The first thing I'm going to do is start like we did before, and I'm going to find the cosine of 0. So here's cosine. The cosine of 0 is actually 1, so I'm going to have to slide my paper back and forth here. All right, then we've got the cosine of 90, which is 0. The cosine of 180, which is negative 1. The cosine of 270, which is 0. And the cosine of 360, way down here at the bottom, is positive 1. All right, let's go back and do negative 90. Remember, negative 90 plus 360 was the same thing as 270. For 270, I got out 0, so this is also going to be 0. Negative 180 plus 360 is the same thing as positive 180. I got out negative 1, so this is going to be negative 1. Negative 270 plus 360 was 90. For 90, I got out 0. And negative 360 plus 360 was 0. I got out 1. All right, so here's my chart for cosine. All right, so let's start by graphing this point, 0, 1. So at 0, I'm going to go up to 1 and put a dot. Notice this does not go through 0, 0 like sine did. At 90 degrees, I'm going to go down to 0. At 180 degrees, I'm going to go to negative 1. At 270, I'm back to 0. And at 360, I'm at 1. All right, so that's the right-hand side. So now let's look at the left-hand side. So at negative 90, I'm at 0. So there's a 0. At negative 180, I'm at negative 1. At negative 270, I'm back to 0. And at negative 360, I'm back up at positive 1. Now this is going to look very similar to sine, but it's just going to be shifted over. So I'm going to start right here, and I'm going to start drawing my graphs. Remember, these low points are my mins. These high points are my maximums. So there's the right-hand side. Left-hand side, I'm going to go through 0 down to negative 1. There's my minimum. And then go back up and curve it to the other side. So here's my cosine function. So sine and cosine look very similar. They're just shifted 90 degrees to the right or to the left. All right, the last one we're going to look at is our tangent function. Now, this is on your very last page right here. So there's my tangent function right there at the top. All right, so when we go to graph tangent, we're going to start with 0 and do the same similar things. But first, I'm going to label my axis like we did for the others. 1 and 2 above, negative 1, negative 2 below. Remember, we're going out 3 units in each direction. And I'm writing my quadrantal angles down. 90, 180, 270, and 360. And then we go backwards and do the negative angles exactly the same way. Every 3 units, we're putting a quadrantal angle on that x-axis. All right, so my axis is set up. All right, next thing we're going to do is we're going to graph this chart using our table to try to figure out what my tangent functions are. All right, so let's start with tangent of 0. Well, the tangent of 0 happens to be 0. All right, then we've got 90 degrees. The tangent of 90 is undefined, which means it does not exist. You could put U and D there if you wanted to. All right, 180. The tangent of 180 happens to be 0. Then we've got 270. The tangent of 270 is once again undefined, so does not exist. And then 360. The tangent of 360, way down here at the bottom, is back to 0. So you notice you got 0 does not exist, 0 does not exist. We got a pattern going on. All right, back the other way. Negative 90 we said was the same thing as 270, so that does not exist. Negative 180 is the same thing as positive 180, so that's 0. Remember, I'm adding 360 there. Negative 270 is the same thing as 90, so that does not exist. And negative 360 is the same thing as 0, which is 0. Okay, so we're going to go and graph each of these zeros first. So let's start here. At 0, I'm going to put 0. So 0, 0. At 180, I'm going to put 0. And at 360, I'm going to put 0. So these are my zeros here. All right, going backwards. At negative 180, I'm also going to put 0. And at negative 360, I'm going to put 0. All right, anytime we have a D and E, that means we have an asymptote going on. So these are going to be vertical asymptotes. So at negative 90, this does not exist, which means this graph cannot touch this line, a vertical asymptote. At positive 90, we also have it does not exist. All All right, if you also notice at negative 270 and at positive 270, we both have does not exist. So these are, again, going to be some vertical asymptotes here. All right, now, to sketch the graph of what tangent looks like, let's just look at the middle of this graph right here. So let's look at 0. So here we got 0, 0. This is 30 degrees, this is 60 degrees, and this is 90 degrees. So let's just look at 30 degrees first. We're going to find the tangent of 30. So the tangent of 30 is the square root of 3 over 3. So I'm going to use my calculator to plug that in just to kind of figure out what that number is. The square root of 3 divided by 3 is 0.57, so almost 0.6. So at 30 degrees, I'm going to go up to 0.6. Now remember, this is 0.5 and this is 1, so it's going to be just barely above 0.5 right there. All right, next thing, since this is 30, this is going to be 60 degrees. So I'm going to find the tangent of 60 degrees. So here's tangent, here's 60, so the tangent of 60 is the square root of 3. So next thing I'm going to do is plug in the square root of 3. Well, that's 1.7, kind of rounded there. All right, so this is 60 degrees, 1 here, 1.5 here, 1.7 is kind of similar to that right there. All right, so it looks like it's just going to kind of curve up like a parabola. But let's figure out what happens to this other side over here. So this right here is negative 30. So the first thing I'm doing is I'm going to do negative 30. I'm going to add 360 to find that coterminal angle, and that's the same thing as 330. If I look on my chart, the tangent of 330 is negative square root of 3 over 3. Well, the square root of 3 over 3 happened to be 0.6 roughly. So this is negative 0.6 roughly. So at negative 30, I'm going to go down to negative 0.6. All right, then I'm going to do the same thing for the tangent of negative 60. If I take negative 60 and add 360, I get out 300. And I'm going to find the tangent of 300. Here's tangent. Here's 300. That's negative square root of 3. Remember, the square root of 3 was roughly 1.7. So this is going to be negative 1.7. So here's negative 60. Here's negative 1. There's negative 1.5. Negative 1.7 is about right there. All right, so if you look at this graph, from the origin to the right is going to be a parabola that opens up. From the origin to the left is going to be a parabola that opens down. Now, you should have noticed this graph back from Algebra 3. In Algebra 3, we looked at this, and this was my x cubed graph. So basically, tangent is just a bunch of x cubed graphs. So if I start here, I can draw my x cubed function. And I can start right here and draw this as my x cubed function. All right, now let's look at these two extremes right here. Negative 360, I want the right-hand side of the graph. The right-hand side of the graph was the part that opened up. At positive 360, I want the left-hand side of the graph. The left-hand side of the graph was the part that opened down. So that's the graph of my tangent function. You got asymptotes floating within here. All right, next thing we're going to look at is trying to find the domain, range, zeros, and asymptotes of each of these functions. We're going to go back to sine right here. And we've talked about domain, range, zeros, and asymptotes of all of this stuff before. I'll try to scoot it over as we go right here. Right, so I want to try to show the function, which is sine, and show this chart as we also go through here. All right, so let's look at sine. The domain for sine keeps going all the way to the left and all the way to the right. So we call that all real numbers. So right here, I can write this as all real numbers, my real number sine. Or look at my range. I want my smallest and my largest y values. My smallest value is negative 1. My highest value is positive 1. So it's trapped between negative 1 and positive 1. So we write like this, negative 1 less than or equal to y less than or equal to positive 1. All right, zeros. Zeros is where this touches or crosses the x-axis. Well, it crosses it here, negative 360, negative 180, 0, 180, and positive 360. Now, since both of these are the same thing, I can write this as plus or minus 360. Both of these are the same thing, so plus or minus 180, and then I've also got 0. So I'm going to list these as x equals, because it's x-intercepts, zeros, 0, plus or minus 180, and that's in degrees, and then plus or minus 360. Now, be mindful, we could do this whole thing in terms of radians as well. Now, we'll be changing our degrees over into radians. All right, asymptotes. Asymptotes, vertical or horizontal asymptotes, are usually represented with those dotted lines like we had for tangent, but right here for sine, we don't have any. So asymptotes, I have none, so I'm going to put 0 with a slash through it. All right, scoot this thing over. Still looking at sine right here. Two things I have to worry about. First thing I have to worry about is the period of the function. Now, the period of a trig function is how often a graph repeats. As you notice, this thing keeps going up and down, up and down, up and down. So I'm going to try to find one rotation for this sine function. Let's start at 0. If I start at 0, I'm concave down, and then I'm concave up. And then if I look right here, it's going to start over again. Concave down, and then concave up. So from 0 to 360 is one rotation for sine. Now if I look over here, there's another rotation. Concave down, concave up, concave down, concave up. So I got to have a down and an up in order to get one full rotation. So the period for this function is 360 degrees, or 2 pi if I was doing this in radians. All right, we've also talked about even and odd. Even means the function is symmetric with the y-axis. Odd means it's symmetric with the origin, or it could be neither. All right, so if I look at this function, it is not even because it does not flip over this y-axis right here. Is the function odd? Does it rotate around the origin? It sure does. If I take this and rotate around the origin, I'm going to get to this other side right here. So sine is an odd function. Now, we also talked about this in section 5.3 with our properties. Sine is an odd function. All right, next one let's focus on is cosine. So I'm going to take cosine, I'm going to move this thing up. All right, so here's my cosine graph. And we're also going to look at cosine inside of my chart right here. All right, so there's cosine. All right, looking at cosine, first thing I want is my domain. Domain, all the way to the left, all the way to the right. So once again, that's all real numbers. Range, just like sine, it's down at -1, it's up at +1. So that's trapped between -1 and +1. So we write exactly the same way. All right, next thing I'm looking for are my zeros. Zeros is where it crosses the x-axis. So that's at -270, -90, +90, and +270. So can we write these as a simplified form? Of course. Plus or minus 270, plus or minus 90. So x equals plus or minus 90 and plus or minus 270. All right, next thing we want is asymptotes. So we don't have any vertical or horizontal asymptotes because we didn't get anything that does not exist up here. So here, I don't have any. All right, let's scoot this thing over. Next thing we want is the period of this trig function right here, okay? So let's look at this period right here. We're trying to find that concave down, concave up, right? So if I start right here, there's my concave down, and then here's my concave up. So the period for this function falls between -90 and +270. So let's count right here. This is 90 degrees. This is 90 degrees. From here to here is 90 degrees. And from here to here is 90 degrees. So I got 1, 2, 3, 4 intervals that are 90 degrees. So 90 times 4 is 360. Or you can say 90 plus 90 is 180. 180 plus 90 is 270. And 270 plus 90 is 360. So that's concave down, concave up. So the period for cosine was the same as sine, which is 360 degrees. All right, now, this last thing that I need to find is if this thing is even, odd, or neither. Well, first thing, is it symmetric with the y-axis? It certainly is, because the right-hand side matches this left-hand side. So this right here is an even function. And we talked about that also when we talked about cosine and secant were my only two even functions inside of my graph. All right, the last one we have for this section so far is tangent. So let's look at our tangent graph, which is right here. And let's see if we can't figure out our chart to go with tangent. All right, now tangent's all the way at the bottom of my sheet right here. So what I'm going to do is I'm going to fold this down just so we can see all of this that's going on inside of tangent right here. All right, here we go with tangent right here. Tangent, first thing I want is my domain. Well, my domain is everything, but these does not exist. And these does not exist happens to be my vertical asymptote. So I'm going to say everything. So I'm going to say all real numbers except x cannot equal, and I'm going to list these asymptotes out. -270, +270, -90, +90. So I can say it can't equal plus or minus 90 or plus or minus 270. And remember, those came from my asymptotes right here. Plus or minus 270, plus or minus 90. All right, next thing I want is my range. Look at my range. It's going down, it's going up. So this right here is all real numbers. It's going everywhere. All right, next thing I'm looking at, domain range, is I want my zeros. All right, zeros is where it crosses the x-axis. Well, it's at -360, -180, 0, 180, and 360. So I can say plus or minus 360, plus or minus 180, and 0. So we're going to say x equals, we're going to start with our smallest 0, then plus or minus 180, and then plus or minus 360. All right, that's my zeros. All right, next thing we want are our asymptotes. Look at my asymptotes. They're right here at these lines. Or I can look up here. It's everywhere where this thing does not exist. So since we have vertical asymptotes, we need vertical lines. So that's x equals plus or minus 270, plus or minus 90. So I'm going to go with my 90 first since this is smaller. And then plus or minus 270. All right, next thing we want to know is the period of this trig function. Now this should be pretty easy. If you notice, this is one rotation, and it just keeps repeating itself. So let's look at how many degrees it is between these two asymptotes right here. We've got 90 degrees from negative 90 to 0, and we also have another 90 degrees from 0 to 90. So 90 plus 90 gives me my period, which is 180 degrees. So the period for tangent is 180 degrees. Let me skip that over so you can see it. All right, the last thing we want to know is this function even, odd, or neither. Well, if it's an even function, it should be symmetric with this y-axis, and it's not. Does it rotate around the origin? It sure does, because this right here is going to move it around. Remember, we talked about x cubed also being an odd function. So tangent is an odd function. All right, so that's my three main trig functions: sine, cosine, and tangent.